I will review about the trigonometric substitution and the trigonometric integral in this video. So the first thing that we're gonna do is gonna be question 5, integrate from 1 to 2 of x squared square root 4 minus x squared dx. And so the thing that you see here is gonna be, you see 4 minus x squared. Okay, so this guy will be a square minus u square. So you have a equal to 2u equal to x, and the minus sign you use sine theta. So we're gonna let x equal to 2 sine theta. Okay, and you have dx equal to, okay, so dx will be dip side is gonna be 2 cosine theta d theta. So we gonna have to change the limit as well. So you're gonna have x equal to 1. Okay, so you have x equal to 1. X equal to 1. So you get 1 equal to 2 sine theta. So you get sine theta equal to 1/2. So you have theta equal to pi over 6. Okay, and you have x equal to root 2. So you have root 2 equal to 2 sine theta. So you get sine theta equal to root 2 over 2. So you get theta equal to pi quarter. Okay, so we're gonna substitute by the trig sub. So you get these two guys, 2, 1, 2. Okay, and you have dx. Okay, you're gonna have to find 4 minus x squared for me also. So for 4 minus x squared, this guy will be 4 minus 2 sine theta square, and this will allow you to have 4 minus 4 sine square, and you have 4 1 minus sine square. So this one will be 4 cosine square. Okay, so this is what we have. And you see that after you have everything set up like this, you'll be able to plug in quite easy. So for this guy, it's going to be integrate pi quarter to pi 6. Okay, so you have integrate, no, I switch it. So it's going to be pi 6 to pi quarter. Okay, and you're gonna have x squared turn out to be sine 2 sine theta square, and you have square root 4 cos theta square, and dx will be 2 cos theta d theta. So let me highlight this one. So the green one for dx, you have x equal to sine theta, and 4 minus x squared turn out to be 4 cos squared. Okay, so this one is the trig sub. And then you're gonna simplify this one. So it's gonna be integrate pi 6 pi quarter, and this will be 4 sine square multiplied with 2 cos theta, and multiply with another 2 cos theta d theta, and this one will be 16. Okay, and integrate pi 6 to pi quarter. sine square multiplied with cos square. Okay, so this one you can just have even power of sine, so they are even power of sine and cosine. So you're gonna change by using the formula. So this guy turned out to be 1 minus double angle 1 plus cos double angle over 2. So this is the identity that we use when we deal with both of power of sine and cosine turned out to be even. And you get 1 minus cos squared 2 theta over 4. Okay, and this guy will be what? This guy will be uh, 1 minus cos squared, so it's going to be sine squared 2 theta over 4. Okay, so it's going to be sine squared 2 theta over 4. And this one will be, you see that you're going to integrate sine square, you're going to change to another double angle. So it's going to be 1/4 outside, and it's going to be 1 minus cos double of 2 theta over 2. Okay, so this one will be just the thing that you use to integrate. So you see that you also have 1/16 that can cancel with 2 and 4 here. So it's going to be 8. So it's going to be 2. Okay, so it's going to be 8 down here. So it's going to be 2. So you would get 2 integrate pi 6 to pi quarter of 1 minus cos 4 theta d theta. Okay, and integrate cos, you get sine, right? So this one will be theta minus sine 4 theta over 4 from pi 6 to pi quarter. And you have 2, you get pi quarter minus pi 6. Okay, that one term. And you have minus of sine pi, so it's going to be 4 pi over 4. Okay, so this one will be, I need 1/4 outside. So you need 1/4 outside, and you get sine 4 pi over 6. Okay, so this guy becomes sine pi equal to 0, and this guy become sine 2 pi over 2, 2 pi over 3, and sine 2 pi over 3 is root 3 over 2. Okay, and pi, what pi 4 minus pi 6, so this guy become what? Become 3 minus 2, so it's going to be pi 12. Okay, so it's become pi 12. So for the final answer, you would just have pi over 6. So you just look at the red guy. So you multiply with 2, so it's going to be pi over 6, and it's going to be plus root 3. Okay, so it's going to be pi over 6 plus root 3 for final answer. And then mistake, another mistake. So it's going to be root 3 over 2. 2 multiple, so it's going to be root 3 over 4. Okay, so this one is the trick sum. And the thing that I like you to see will be intricate how to integrate sine square cos square. Okay, so this is I teach you how to integrate sine square cosine square also for this example. The next one, you see that you have 1 over x squared plus 2x plus 2 square. So you see something like this before that you need to complete square for sure. Okay, so I'm going to highlight the yellow guy first. So the thing that you see turned out to be x squared plus 2x plus 2, and this become you complete square, so you get x squared plus 2x plus 1 plus 1, so it will be x plus 1 square plus 1. So you have u equal to x plus 1 and you have a equal to 1, so you substitute. Okay, so you're gonna let and use 10 theta because of the plus sign. Okay, so you have the plus sign here, so you use 10 for sure. So you're gonna let u, so you let x plus 1 to be 10 theta. Okay, so this will allow you to just have this one, and you have dx equal to dip 10 is secant square theta d theta. And you see that you have x plus 1 square plus 1 turn out to be secant square secant 10 square theta plus 1, so it's gonna be secant square. Okay, so this allows you to just have the yellow guy nicer. So this one is the yellow guy, and the yellow guy becomes just secant square. Okay. So for the substitution, you're gonna just integrate 1 over secant. Okay, so you 1 over secant square, and then you square outside. And what is dx? Dx will be the green color. Dx. For dx is gonna be secant square theta d theta. Okay. And this guy will be integrate 1 over secant to the 4th theta multiplied with secant square theta d theta. Okay, and you'll be able to get rid of secant and secant, so you end up with 1 over secant square. So it's going to be integrate cos square, integrate cos square, and integrate cos square turned out to be integrate 1 minus, not 1 minus, 1 plus cos double angle. Okay, and this guy will be 1/2, and integrate 1, you would get theta, integrate cos, you get sine theta. Okay, so this one, let me write it here, 1/2, right? So it's going to be theta, and integrate cos, you get sine 2 theta over 2. That's the, and finally, you're gonna change the function in terms of x. So you have tan theta equal to x plus 1 over 1. Okay, so this one will be opposite over adjacent. So okay, so in this case, you're gonna have the right triangle. Okay, so for this one, you're gonna have theta. Okay, So you have opposite equal to x plus 1. Okay, and you have adjacent equal to 1, and this guy will be square root of x squared, x squared, x plus 1 square plus 1. Okay, so you're gonna have sine 2 theta is gonna be 2 sine theta cos theta. So it's gonna be what? It's gonna be 2, and sine will be what? Sine will be opposite. So it's gonna be x plus 1 square root x plus 1 square plus 1. Okay, multiply with 1 over square root x plus 1 square plus 1. So this will become 2x plus 1 over the bottom guy that you have is x squared plus 2x plus 2, okay, from the question, from the yellow guy. And you see that, okay, it's come from the yellow guy here. You see that theta will become 10x plus 1, okay, and then you're gonna put everything, so it's gonna be 1/2 of 10 x plus 1, okay, plus sine 2 theta over 2. So it's going to be 2 will be cancelled. So it's going to be just x plus 1 over x squared plus 2x plus 2. Okay, so it's going to be x plus 1, uh, uh, not x plus 1, x squared plus 2x plus 2. Okay, and then everything plus c. Okay, don't forget that you have 1/2. Okay, so you have divide by 2, divide by 2. Okay, so divide by 2. So this one get rid of. Okay, okay, so this one will be your final answer in terms of x. The next one, okay, so the next one, so you see this one seems different from the other. However, the trick sub will be the same thing. So you see 1 plus log x square. So this guy is a square plus u square. So you have u a equal to 1, u in this case equal to log x. Okay, so you have a equal to 1, u equal to log x. And you're going to have du equal to dip log x is going to be 1 over x dx. Okay, so you have 1 over x dx, and you're gonna substitute everything. So this one will be your du, right? 1 over x dx. So you see that dx over x will be du, and your u equal to log x. And the thing that you need to find, another one will be 1 plus log x squared. So for this guy, it's gonna be 1 plus du equal to 1 over x log x. Let's change this guy a little bit. Let's change this guy a little bit. So you have this guy is gonna be integrate square root 1 plus u square. Okay, so you get u and du. Okay, so this is what you have so far. Let me make this guy a little bit nicer. Okay, and you have u. Okay, and you're gonna substitute u equal to tan theta. Okay, so you have u equal to tan theta, so you get du equal to dip tan is secant square theta d theta, and you have 1 plus u square equal to 1 plus tan square equal to secant square. So this will become square root secant square, and what is u in this case gonna be tan theta, and you have secant square theta d theta. Yeah. So you will obtain secant theta times secant square over tan theta. Okay. And for this one, okay, let me combine this guy a little bit. So this will become integrate secant to the third. Okay, so it's going to be secant to the third theta over tan theta d theta. So it's not going to fall into like a secant tan that we have been studying. Okay, so this thing turned out to be the thing that you're gonna change into sine cosine. Okay, so I'm gonna say that try to change to sine cosine. Okay, so we're gonna change to sine and cosine. Let me put theta also. Okay, so for this guy, it's gonna be integrate 1 over cos to the third theta, and you have tan is sine theta over cos theta, and you have the theta on top. Okay, and this will be integrate, and you have cos square theta sine theta d theta. Okay, okay, and you see this one that you have 1 over cos over sine. Okay, 1 over cos over sine. And if you recall, I used to do this one once before. You see one up here. Okay, so you see one up here. The thing that we gonna do is gonna be we're gonna change 1 to cos square plus sine square. Okay, so you integrate 1 here is going to be cos theta square plus sine square theta over, and the bottom guy is cos square times sine theta, and this guy is the theta, so this guy is the blue color. And you see that this will allow you to have two terms. Yeah, so this will allow you to have two terms. So it's going to be integrate cos square over cos square sine, okay, plus integrate sine square over cos square sine d theta, and cos cancel each other, and you have sine and sine cancel each other, so you would get integrate 1 over sine theta. Okay, this is one term, plus integrate sine over cos square d theta. Integrate 1 over sine. 1 over sine in this guy is going to be cosec. Okay, 1 over sine is cosec. And integrate cosec, you have the formula log absolute cosec theta minus cotan theta. Okay, so that will be just this guy. And for integrate sine over cos square, this one can be done by just substitution. So you would let u equal to sine theta, and you have du equal to cos theta d theta. Okay, and sorry, you have u equal to cos theta. I told you the opposite. So u equal to cos theta and du is negative sine theta d theta. Okay. And this one because you have psi to the odd power, so that you get this one. And you get what? You get integrate. Okay, so this one will become integrate negative du over u square. So it's going to be negative 1 over. Okay, so it's going to be negative 1 over uh, cos theta. Okay, so it's going to be negative 1 over cos theta. Let's kind of too fast. Okay, 1 over u. So this guy will be negative of so it's become negative of uh, sorry, it's going to become negative. I forgot one negative sign, right? So it's going to be negative of negative. Okay, so it will become positive. So it's going to be 1 over cos theta, and this guy will be sec theta plus c. Okay, so we have plus secant theta plus c for this term. Okay, and that's it for final answer. You may also notice that, okay, so you may also notice that sine theta over cos square can be written as sine theta over cos 1 over cos, and this guy turned out to be tan sec. So indicate tan sec is sec. Okay, you can do this one this way also. Okay, so you get something faster. Okay. For final answer, you need everything in terms of x. So we know log x equal to tan theta. Okay, so we know log x equal to tan theta up there. Okay, so u equal to tan, u equal to log x, so it's going to be log x equal to tan theta. You draw a triangle. So this one will give you a right triangle like this, and shoot. Okay, so shoot. It's at the margin, so I not be able to control it nicely. So for this one, you're gonna have log x for opposite. Okay, and you have 1 on this side, and you have square root of log x square plus 1 for the other side. So in this case, you're gonna just have this guy, and you're gonna answer in terms of cosec cot. So let me answer this guy by using this triangle. So you see that cosec will be 1 over sine, so it's hypotenuse over opposite. So it's going to become log, okay, and it's going to become square root log x square plus 1 over log x. Okay, so that one term. And cot will be 1 over log x. Okay, and integrate sec. Okay, sec will be what? Sec will be what is called 1 over cos. So it's going to be square root log x square plus 1 and u plus c. Okay. So this one will be your final answer in terms of log Okay, so this one just the final answer. Let's do last question. Last question, you like to integrate from negative, not negative, square root 3 to 3 of something messy. So for this one, you see that you're going to use secant. Okay, so it's pretty clear that you're going to use secant. So you're going to see 4x squared minus 9. So this guy is 2x squared minus 3 squared. So you have u equal to 2x and a equal to 3, and you will use secant theta. Okay, so you're gonna let 2x equal to 3 secant theta, and you have 2 dx equal to 3 dipsec is sec theta tan theta. Okay, and you're gonna have to evaluate 4x squared minus 9, so it's gonna be 2x squared minus 3 squared, so it's gonna be 3 sec theta square minus 3 square, and this guy become 9 secant square theta minus 1, so it's gonna be 9 sec square is tan theta. Okay, sorry, tan theta square. Okay, so it's gonna be like this, and then what? And then you're gonna do the limit. So you have root 3 equal to, okay, so you have 2 root 3 equal to, I normally write x equal to root 3, right? So you have 2 root 3 equal to 3 sec. Okay, so you would have sec theta, so it's going to be sec theta equal to 2 over root 3, and you have x equal to 3, so it's going to be 2 times 3 equal to 3 sec theta, so you get sec theta equal to 2, so you get theta equal to, okay, so you're going to get theta equal to pi 6 pi 3. Okay, so for this one you have pi 6 pi 3. Okay, and you have x cubed, so it's gonna be what? X cubed. So what is x? Let me solve for x for you a little bit. So for this guy you have x equal to 3 half sec theta. Okay, so it's gonna be 3 half sec theta. So this will be my x. Okay, so you're gonna have my x cubed turned out to be 3 half sec theta to the third. Okay, and for dx, where's my dx? My dx is here. My dx will be 3 half. Okay, and you have sec theta, tan theta, d theta. Okay, so this one will be your dx. Okay, so you have dx equal to that guy. Let me also give you some color. And on the bottom, you would just have this term. I'm going to highlight the pink one. 4 minus 9, 4x squared minus 9. So it's going to be 9 tan square. So, so this one will be 9 tan square theta to the 3 half. So this one is the pink guy. Okay. So this will be integrate pi 6 pi third. Okay, and you need to multiply everything like this. So just concentrate. So it's going to be 3/4 to the fourth. And how many secant you have? You have 4 secant. So it's going to be secant to the fourth tan theta. And you have the third, and not the third, the square root to the third power. So it's going to be 3 cubed. And this one is going to be 10 to the third. Okay, and d theta is d theta. Okay, so everything turned out to be nice now. And you're gonna have to like do algebra. So for this one, you get 10 square on the bottom. Okay, and you have secant to the fourth. So it's gonna be integrate pi 6 pi over 3, and you have 2 square 2 to the fourth. Okay, and you get 1 over 3 to the third. Okay, and how would I have sec to the fourth, right? You have sec to the fourth over 10 square. Okay, I let you stare at this one a little bit, so this one seems kind of messy. And the thing that you do will be you're gonna get rid of my 3, so it's gonna be 3/16 outside. Okay, so it's 3/16, and you integrate sec to the fourth. So this one, you see that it is even power of secant. So when you have even power of secant, the thing that you're gonna do will be you're gonna write this one as sec square, okay, over 10 square, and you're gonna group sec square 10 square. Okay, so you're gonna group sec square 10 square together. Okay, this is one group, and you're gonna let w equal to 10 theta. So you get dw equal to sec square theta d theta, and this will allow you to change everything into, okay, so 10 pi over 6 will be root 3 over 3, and you have 10 pi over 3 equal to root 3. So you're gonna have root 3 over 3 to root 3. Okay, and don't forget 3 over 16. Okay, so it's 3 over 16, and you have secant square. Okay, so this will be the last term that I will manage. Okay, so you have secant square. Secant square here is 1 plus 10 square. Okay, so this will become, okay, step by step. So for this one is 1 plus 10 square, so it's going to be 1 plus w square, and you have secant square d theta, so this one will be dw. Okay, so this guy will be dw with the root here, and you have 10 square, which is w square. Okay, so I use the color accordingly, and you see that this one will become, okay, wish me luck here, 3/16, and you're gonna integrate from root 3 over 3 to root 3, and it will become 1 over w square minus 1 dw. Okay, so it's gonna be not minus, plus, sorry, and you're gonna just have to integrate something simple. Okay, I'm gonna use this space to integrate, so it's gonna be 3/16. I integrate this guy, so I get 1 over w negative plus w, and I'm gonna plug in root 3 and root 3 over 3. Okay, and this one will become something messy. Okay, so it's going to be negative 1 over root 3 plus what is it going to be? It's going to be root 3 subtract, so it's going to be plus, right? So it's going to be root 3, so it's going to be 3 over root 3. Okay, so it's going to be 3 over root 3, and it's going to be minus this guy is going to be 1 over root 3. Yeah, so it's going to be root 3 over 3. Okay, so this is what you get so far, and you're gonna see that you have 3 over root 3, and root 3 can combine to each other, so this guy are identical, and negative root 3 over 3 and 1 over root 3 are the same identically as well. This guy. So it's gonna be double. Okay, so this one will be 316, and you have 2 root 3 minus 2 over root 3. Okay, it's turned out to be kind of nice, so it's going to be 38 root 3 minus 1 over root 3 for final answer. Okay, drop and you see the whole picture here. Okay, so this one is the whole solution for this one. Let me just box this guy a little. Okay, so this one. Okay, so that's all for this next problem. I did 4 examples on trigonometric substitution for you, and you see that sometimes messy like this one is going to be kind of a lot of involving trigonometry and algebra, so it's not that simple to do. Okay, however, the technique of integration is not simple subject.